Taiwan's weather models failed spectacularly. Typhoon Fung-Wong dumped 40% more rain than predicted. Overwhelming rivers, flooding streets, and catching communities off guard. Satellites, radars, and ground sensors all underestimated the storm, leaving residents and emergency services scrambling. The question on everyone's mind: how could every system have missed this? What began as a routine forecast quickly spiraled into chaos. Models had indicated moderate rain, perhaps a few heavy showers. Residents might have expected wet streets, maybe a few flooded drains instead. Clouds swelled rapidly over the western plains, gusts of wind ripped through neighborhoods, and light drizzle quickly escalated into torrential rain. Within hours, streets turned into rushing rivers, bridges groaned under the weight of water, and emergency crews scrambled to respond to alerts that came too late. The scale of the model failure is alarming. In some valleys, rainfall totals reached 350 millimeters in less than a day. Months of precipitation condensed into mere hours. Rivers rose faster than expected, urban drainage systems overflowed, and even streets designed to handle heavy rain became treacherous torrents. Emergency services were forced into split-second decisions, prioritizing which areas to save and which to monitor, knowing that delays could cost lives. Families in Hualien were trapped in their homes as streets disappeared beneath churning waters. Children clung to parents while pets bolted in panic. Valuables floated away or were crushed by debris. In Taichung and Nantou, landslides blocked roads, power lines snapped under debris, and villages became isolated. Rescue teams improvised, navigating dangerous terrain to reach those trapped by nature's sudden fury. Taiwan's mountainous terrain amplified the storm dramatically. As moist air from Fung-Wong hit steep hills and peaks, it was forced upward, cooled rapidly, and condensed into torrential rainfall, a process called orographic lift. Certain valleys experienced intense bursts of rain that satellites and models failed to detect. Narrow rivers swelled, bridges buckled, and streets transformed into torrents. Small, localized convective cells formed suddenly, funneling massive volumes of water into tiny areas. Imagine a valley painted bright red on a radar map with hundreds of millimeters of rain in mere hours, while the surrounding landscape remains lighter blue, falsely suggesting moderate rain. This is the blind spot that caught residents off guard. Entire neighborhoods were submerged before warnings could be issued, forcing emergency services to act in real time, improvising under pressure. The human cost became visible immediately. Families scrambled to gather pets, valuables, and essentials while floodwaters invaded homes. Children screamed, terrified by the roar of water and the chaos around them. Emergency personnel risked their own lives to rescue trapped residents, wading through debris-filled streets and navigating landslide-ravaged roads. By mid-afternoon, consequences escalated dramatically. In Nantou, landslides cut off entire neighborhoods. Trees toppled onto roads, power lines snapped, and communication networks failed. Bridges and roadways, engineered for extreme but expected events, were stressed beyond their limits. Even areas initially predicted to face moderate rainfall suffered catastrophic flooding. Vehicles stranded in rising waters became hazards themselves, blocking evacuation routes. Roads rapidly transformed into streams, making it impossible for emergency crews to reach some areas quickly. Urban drainage systems were overwhelmed. Rivers threatened to breach embankments and dams approached critical capacity. Each failure compounded the next, creating a cascade of challenges for authorities. Emergency crews faced impossible decisions: which areas to prioritize, which evacuations to accelerate, and how to communicate effectively when communications were down. Shelters filled faster than anticipated. Volunteers and rescue teams coordinated via mobile hotspots and satellite phones, often improvising routes to reach trapped residents. Why did Fung-Wong produce 40% more rain than models forecast? Meteorologists scrambled for answers. Models integrate wind patterns, moisture content, pressure gradients, and topography to simulate storm behavior. Yet, even with modern computing power, these are approximations. Experts debated fiercely. Some argued the typhoon stalled over the Pacific, drawing moisture for longer than predicted. Others suggested that satellites underestimated water vapor levels. A third camp pointed to Taiwan's rugged terrain, which channeled rain into narrow valleys, amplifying local impacts. While they debated, rivers surged, roads vanished beneath floodwaters, and emergency responders acted in real time to save lives. Visualizing the failure. Imagine a digital model smoothing out peaks of rainfall into a gentle average, a few centimeters here, a few there. In reality, convective bursts unleashed torrents in narrow pockets, turning streets into dangerous rivers while models predicted only a drizzle. Fung-Wong is part of a larger, alarming pattern. Rising ocean temperatures, increased atmospheric moisture, and shifting wind patterns are making typhoons stronger, wetter, and more unpredictable. Models attempt to anticipate typical storm behavior, but climate change introduces variables they are not yet equipped to fully capture. Stalled storms, convective bursts, and supercharged rainfall events will likely occur more frequently. Fung-Wong serves as a warning, a live demonstration of the gap between human preparation and nature's raw power. Taiwan's experience is a case study for the global scientific community. Predictive models are only as accurate as their assumptions and inputs. The unexpected intensity forced authorities to rethink both forecasts and emergency responses in real time. The haunting question hangs over Taiwan. What if the next typhoon exceeds predictions by 60%? Could dams fail? Embankments collapse? Entire urban centers flood? Could landslides and flash floods trap entire villages? Fung-Wong was a warning, a glimpse into the stakes when extreme weather meets limited infrastructure and unprepared communities. Radar feeds showed rapidly intensifying storm cells. Satellites recorded concentrated moisture in narrow valleys, and ground sensors reported near-record rainfall. Despite the data, models failed to integrate it in real time. The tension between prediction and reality left scientists, emergency services, and residents facing the storm's raw power with little warning. By early morning, the human toll became undeniable. In Hualien, a family of 5 waded through chest-deep water to reach a shelter. Carrying only essentials, a farmer in Nanta saw decades of crops washed away by mud and water. Emergency crews rescued elderly residents from rooftops and guided children through flooded streets. Each story illustrated the human cost of model failure and the urgency of rapid decision-making. Social media amplified the chaos, sharing videos of streets disappearing, bridges strained underwater, and landslides cutting off villages. Anxiety spread faster than the rainfall. Fung-Wong was more than a meteorological event. It was a real-time lesson in human resilience and the limits of prediction. By evening, Taiwan's emergency services had fully mobilized. Shelters opened, high-risk zones were evacuated, and traffic was rerouted. Yet Fung-Wong's unpredictability persisted, forcing meteorologists and hydrologists to continuously analyze evolving data. Radar feeds showed deep reds spreading faster than predicted. Satellites captured concentrated moisture in narrow valleys, and buoy data revealed ocean currents fueling the storm. Experts argued that the typhoon's stalling motion over the Pacific created a feedback loop, drawing moisture at unprecedented rates. Others highlighted Taiwan's terrain, which funneled rainfall into narrow channels, amplifying local impacts. The debates underscored a single truth: models cannot account for every variable, and the unexpected can escalate into disaster in moments. Fung-Wong exposed weaknesses in roads, bridges, embankments, and drainage systems. Landslides blocked access, low-lying urban areas flooded, and neighborhoods designed for historical extremes were overwhelmed. Emergency plans were tested to the limit. Rapid coordination between local governments, volunteers, and national authorities became essential to prevent even greater loss of life. Models averaged rainfall across regions, smoothing out extreme spikes. Meanwhile, convective bursts concentrated water in tiny valleys. Picture a topographic map. Vast regions appear lightly drenched, while hidden pockets explode with torrents. This is where residents were blindsided. Streets transformed into rivers, homes filled with water, and bridges groaned under stress before warnings could reach communities. Extreme rainfall events are becoming the new normal across East Asia. Rising seas, higher moisture content in the atmosphere, and shifting wind patterns are fueling more frequent and intense typhoons. Fung-Wong demonstrates that even sophisticated forecasting systems can be outpaced by climate change, reinforcing the need for resilient infrastructure and real-time preparedness. What if the next typhoon is stronger than Fung-Wong is now a critical question. A 60% exceedance in rainfall could overwhelm regions, trigger dam failures, collapse embankments, and flood entire cities. Fung-Wong shows that nature will always have surprises, and humans must act faster than models can predict. Emergency supplies, evacuation plans, and real-time monitoring are more important than ever. Communities must be ready, infrastructure reinforced, and authorities capable of rapid response. Fung-Wong was a warning. The next storm could be worse, and lessons must be learned before it arrives. As waters receded, Taiwan reflected on sobering lessons. Rapid decision-making, local knowledge, and communication proved as vital as any model. Fung-Wong revealed the limits of human foresight, the unpredictability of storms, and the necessity of vigilance. The storm's legacy leaves a lingering question. If Fung-Wong exceeded expectations by 40%, what will the next typhoon do? Could multiple simultaneous storms overwhelm emergency response entirely? Could infrastructure fail under modern climate conditions? These are not abstract possibilities. They are urgent realities demanding attention. Communities realized how quickly events escalated, how much they relied on rapid response, and how every infrastructure decision could save or endanger lives. Fung-Wong left a clear message. Preparation cannot wait for certainty or perfect prediction. Awareness, planning, and respect for nature are non-negotiable. Hit subscribe and turn on notifications so you're the first to know when extreme weather strikes. Don't wait for the models. Stay informed in real time.